low-carbon innovation. How innovative ocean solutions can address the climate crisis. Katja Matthes, GEOMAR Helmholtz Centre for Ocean Research, Kiel.
On November the 9th, 1989, as a teenager living in Berlin, I found myself in close proximity to the historic events unfolding around me. Yet despite the nearness, the true significance of that moment was difficult to fully comprehend at the time.
Hello, I'm very excited to be here after 35 years, and let's have a look what happened in the past 35 years in Berlin. You can see here temperature change since the pre-industrial times, and you can see this dramatic increase in temperatures. We are about to cross the 2-degree Celsius line, and if you look globally, we have reached already 1.5 degrees Celsius. So this means we've already reached the Paris goal. We will not stay under the Paris goal. That's bad news, but there will be more positive news during my presentation. So we know what the reason is, and the reason is the increase in CO2. You can see here the CO2, atmospheric CO2 content measured in Mauna Loa in Hawaii. Since pre-industrial times, it shows the CO2 content from 1960 onwards, and you see the steep increase. So we started at 270 ppm in pre-industrial times. We reached now, this year in June, 427 ppm. So I was born at 331 ppm. You can look where I was born. And so in my lifetime, there was an increase in almost 100 ppm, which is really astonishing. And you can see the climate stripes and the temperature increase, which is practically linear with the CO2 increase. And this slide is called or titled Climate Inaction Stripes, because you can see all the UN climate change conferences, the first IPCC assessment report, the Paris Agreement in 2015, but nothing happens. It just steeply increases. So this linear long-term relationship is long known. We know it's due to fossil fuels. Scientists agree climate change is happening. But the good news is we can still do something. And I will tell you what we can do. So the ocean is the largest carbon reservoir on Earth. It has already taken up 30% of CO2 from pre-industrial times. We have a warming. It has absorbed 90% of the warming. So this is good news. The ocean helps us to buffer climate change, but it is also quite threatened. As you can see, these are ocean surface temperatures, and these increased dramatically in the last years. So we reached already 1 degree in the ocean. So the ocean needs help, and it can help us. So we need to balance what's going on. So we still have the choice. And this is one of my favorite figures from the last IPCC synthesis report from last year, which shows the climate stripes again, starting in 1900 until 2020. And in 2020, future emission scenarios start. So this is where it reaches from very low to very high emission scenarios. Currently, we are in an intermediate to high path. So temperature increases. If we continue as we do now, we will reach 2.6 to 3 degrees by 2100. If you look at a child born in 1950, it experiences temperatures of about 1 degree at 70 years old. If you look at a child that was born in 2020, so just a couple of years ago, it will experience temperature changes or temperature effects between 2 to 4 degrees Celsius. So this is a significant change to 2020, but it really depends on our choice. So it depends on the future emissions. So let's have a look at the emissions. And since I'm living in Germany, I took the emissions from Germany in 2021. So you can see here that per year we emit about 700 million tons of CO2. And you can see the different sectors: power plants, combined heat and power, mobility has a large part, business, trade services, industry, households, agriculture, and land use change. So in order to reduce these emissions and to come to net zero by 2050 or 2045, as the German climate protection law states, we have to significantly reduce emissions, avoid and reduce emissions. And this is a quite complicated slide. You don't have to understand it in detail. What I would like you to focus on is the lower part. So we have to reduce and avoid emissions by 90%. So in the year 2050, we have to reduce and avoid, and there will be still some rest emissions, and it will be 50 to 70 million tons CO2 per year. So these last 10% of emissions need to be compensated. And we have to take CO2 out of the atmosphere for these rest emissions that are unavoidable. So it's, for example, from the chemical industry, from the cement industry, and other parts. So unfortunately, we have some, or fortunately, we have some options, but we have to come up with technical solutions. So there is no way that we will reach net zero with natural-based solutions only. There is a small part of natural-based solutions, and I will show you some of them, but the largest part will be with technical solutions, including carbon capture and storage. And so this emission reduction and avoidance is possible. It means a reduction and a net zero economy, which is technically, economically, and socially possible, but it means a complete transformation within one generation. So that's quite a challenge. But the good news is that we can do this, and we have the ocean that can help us. So one method to reduce CO2 in the atmosphere and help us to compensate climate change is ocean alkalinity enhancement. And this is quite complicated, so I would like to spend some minutes to explain what this means. So 70% of the ocean or of the Earth's surface is covered by the ocean. The ocean is the biggest carbon reservoir, so it takes up a lot of carbon, 30% since pre-industrial times. So what happens if CO2 enters into the ocean? CO2 dissolves in seawater and it forms carbonic acid. So it is leading to ocean acidification, which is not very good because it harms marine life, etc. So we have to come up with a method that counteracts ocean acidification. And there is a natural process that goes since the beginning of Earth, and this is sediments that are transported in rivers into the ocean. They put minerals into the ocean and counteract this ocean acidification. So they make the water more alkaline. And we want to use this natural effect and do it with experiments or help the ocean to take more CO2. We do this in these little aquariums. These are big plastic bags, 10 or so, developed in Kiel. This is a picture from Kiel Fjord, where we do enclosed systems experiments. We put minerals like silicate and lime into the water in order to enhance the CO2 uptake of the ocean. But of course, we are looking at the marine ecosystem because we don't want to have the next CO2 problem in the ocean. So right now, we are only allowed to do it in closed structures. It's forbidden by law to do it in the open ocean, but this would be the next step. So it's the High Dumping Sea Convention, which does not allow us to do it. So, but before we do this, really, and propose it as a method, we need this research in the open ocean. So this is one aspect. Another aspect is natural. It's a natural-based one, coastal ecosystem restoration. And this is seagrass. So seagrass stores a lot of CO2. It helps to protect the coasts because it harms the waves, so it reduces waves. It provides food and safe space for marine animals. It filters viruses and pathogens, so it has lots of positive effects. And you see a scientific diver from GEOMAR planting seagrass. This is actually the most effective way of restoring seagrass meadows. But it's very tidy and it takes a lot of time. So we have hobby divers that help us, citizen science projects in the Kiel Fjord that restore with us these seagrass meadows. It helps to store CO2, and it stores more CO2 than forest on land, but there is not enough space in Germany to store lots of tons of millions of tons of CO2 that we would need. So it's very good, and we should do it to protect the marine ecosystem, but it will not help us with CO2 so much. The third and last method is CO2 storage under the seafloor. This method can be very effective for the unavoidable rest emissions. So we can transport CO2 by ship or a pipeline to the seafloor, press it under the seafloor, 800 meters under the seafloor. It will dissolve in sandstone formations. We need a protective layer so it doesn't gas out, because then we have CO2 again in the water, which we don't want. So we press it under the seafloor, it stays there, it's safe, it mineralizes, and it stays there for thousands of years. So this is a method that is already done in our neighboring countries like Norway or Denmark. It works, and the effects on the marine ecosystem are very small if you do it correct. So it's allowed now by the carbon management strategy of Germany. Offshore CCS is allowed. The law is still not in place, but it will be, hopefully, and we need more large-scale projects in order to test this. So I've presented you these three methods: ocean alkalinity enhancement, coastal ecosystem restoration, seagrass, and CO2 storage under the seafloor. In terms of compensation, I told you 50 to 70 million tons of CO2 need to be, these are the rest emissions that need to be stored. So how effective are these three options? The most effective one is CO2 storage under the seafloor. It's more than 10 million tons per CO2 per year. The second one is ocean alkalinity enhancement with 1 to 10 million tons CO2 per year. And the third one is seagrass or coastal ecosystem restoration with 100 kilotons CO2 per year. So to finish, I would like you take up three take-home messages. So our climate is under pressure and needs solutions, and we need climate action fast. We need to drastically cut emissions, and then the ocean offers solutions for the unavoidable rest emissions to counteract climate change, and the ocean is under pressure and needs our protection too. Thank you very much.